Hey guys, Mr. Backward here. In this video, we're going to look at exponents and the quotient rule. So when we're looking at using the quotient rule, that means we're going to have some division happening. So let's look at what happens if we divide a to the 7th by a to the 3rd. So remember, with exponents, having a to the 7th really means that we're multiplying a by itself 7 times. And on bottom, a to the 3rd really means that we're multiplying that a by itself 3 times. Now, because we have multiplication happening on top and on bottom, there's actually going to be some canceling that we can do with the a's on top and on bottom. So I can cancel out 1a on bottom with 1a from the top. I can cancel out another a on bottom with another a from the top. And I can cancel out one more a on bottom with one more a on top. So all of the a's on bottom have canceled out. So we always want to think about there being a 1 being multiplied by all of these things. So there's still technically a 1 on the bottom of this fraction. And if we look across the top, we canceled out 3 of those a's, but there are 4 of them left over. And if we want to shorten that, we can shorten that to be a to the 4th. And when we have a to the 4th being divided by 1, dividing by 1 doesn't change anything, so we just get a to the 4th. Now what I want you to notice with those original exponents that we had a 7 on top and we had a 3 on bottom. Because of the 3 a's on bottom, we were able to cancel out 3 a's from the top, just leaving us with 4 of them. So really what happened in here with that division is we ended up doing some subtraction with the 7 and the 3. 7 minus 3 leaves us with 4. So the quotient rule for division with powers says that you're going to subtract the exponents but keep the bases the same. And this rule only works if the base is the same on top and on bottom. So this example is very similar to the first one we looked at. We could do it the long way where we write out all of these a's, or we can use our quotient rule to make things a little bit quicker. So we have a to the 10th being divided by a to the 4th. I think the quotient rule is going to be a little bit quicker for us to do. So we want to keep the base the same, but we want to subtract those powers. So we would have 10 minus 4, which would leave us with a to the 6th power as our final answer. Next one we're looking at, we have x to the 13th divided by negative x to the 4th. I'm going to ignore that negative for just a second and look at those exponents. We want to keep the base the same, but we want to subtract those exponents. Now let's bring that negative back in. On top, the x is positive, but on bottom, the x is negative. So when you take something that's positive divided by something that's negative, we always get a negative answer. Now doing that subtraction with the powers, if we take 13 minus 4, we're going to get negative x to the 9th power as our final answer. Now this example starts to get a little trickier. I've added some extra things in here, and this says that we're going to use the associative property to simplify this down. So what the associative property says is that we're allowed to make groups out of things, and usually it's helpful to group things that are similar. So what I notice is that we've got these numbers happening on top and on bottom. So I'm going to separate those into one group using a set of parentheses. And then I'm going to separate these variables into a second group by using a different set of parentheses. So if we look at that first fraction with just the numbers, it's 6 over 2. That's our first set. And then if we look at that second set with just our variables, it's x to the 13th over x to the 4th. Now, just doing the division that's happening in here, 6 divided by 2 is 3. And then if we look at using our quotient rule with those variables, we're supposed to keep the base the same, but we subtract those exponents. So if I do 13 minus 4, we get x to the 9th power. So the final answer in here is going to be 3x to the 9th power. Now we're going to do something similar in here. So we have 10z to the 8th over 4z cubed. So I'm going to make a group out of those numbers. So I'm going to put one set of parentheses around that, and I'm going to put a separate set of parentheses around those variables. So we're going to have 10 over 4 as our first fraction, and we're going to have z to the 8th over z cubed as our second fraction. Now notice with this first fraction, that doesn't divide out nicely, but this fraction is reducible. Each one of these numbers are divisible by 2. So if we take 10 and divide it by 2, then we're going to get 5 on the top of the fraction. And if we take 4 and divide it by 2, we're going to get 2 on the bottom of the fraction. So we have 5 halves as that first fraction. Now here with these variables, having z to the 8th divided by z cubed, so we keep that base the same. So we've got z. We subtract those exponents, so it's going to be to the 5th power. Now technically this is still a fraction, and it's over 1. Now what we can do with this is we can multiply these back together. And when you multiply fractions, you just multiply the things on the top. So 5 times z to the 5th is just 5z to the 5th power. And then 2 times 1 on bottom is 2. So for our final answer, we've got 5z to the 5th power all over 2. Now we're going to up the difficulty level a little bit, because now notice that there's more than one variable happening in here. So when we use our associative property, we're going to group up the things that are the same. So we're still going to make a group out of those numbers, so the 18 and the 6. We're going to make a second group out of the x variables, but now this time we're going to make a third group out of the y variables. So we're going to have 18 over 6. We're going to have x to the 8th over x to the 5th. And then our last group this time is going to be y to the 12th over y to the 6th power. Now we're going to take care of all the division that's happening in here. 18 divided by 6, we can do that. 18 divided by 6 just gives us 3. Now that is technically over 1. As we look at that second set of information with those x's, we keep the base the same, so we're going to leave it as x. We subtract those exponents, so we get x cubed. And again, this is still technically over 1. And then for our y's, we've got y to the 12th over y to the 6th, so we keep the y base the same. Doing 12 minus 6, we get y to the 6th power. And again, this is technically still over 1. So now what we're going to do to put these back together, we're going to multiply all of the tops back together. So 3 times x cubed times y to the 6th. Well, we're just going to put those right next to each other and have 3x cubed times y to the 6th power. Now across the bottom, it's just 1s, so this is all over 1. And then when we're dealing with a fraction where the denominator is 1, it's not necessary to keep that denominator in there. So it's going to be 3x cubed times y to the 6th power as our final answer. That's going to be it for this video. Thanks for watching.